Hi guys, this is Unit 1 Study Guide for Geometry. Alright, so if we're looking at number 1, okay, first things first, they're asking us to name some things. So if we're looking at this diagram on number 1, you would see here that, well, we're going to have to use this diagram. So we have a couple points. First point is point A. There's another point, point B, and another point, point C. Now for rays through C, sorry, we can actually remember a ray, and this is of course not a perfect uh, straight ray, but a ray you could draw from B to C. Don't forget to use the markings above the letters. Remember, it's going through C, so your C is not going to be an endpoint for that ray. And we also have AC. Make sure you draw the arrow. Okay, they are rays. All right, name a line through B. So remember, a line has to have at least 2 points, and it's got to go through B. Okay, so AB works. Don't forget to appropriately draw the designation above the letters, and you can also draw one with BC. So there you go. Now a plane. Plane is basically the floor or planet they're all on, so they label it as Fancy P. All right, that'll work. All right, number 2. So we're basically just identifying certain angles. So if you look at number 2, it's asking for angle BCK. Now that would be, let me use a highlighter so you can see what they're talking about. BCK would be there, okay? Now, if you measure with a protractor, you should get 90 degrees, and they also verify right here that the angle measures 90 degrees. Therefore, it has to be, by definition, a right angle. Always right. Okay, next up, number 2. Number 2, it's saying DCG. Okay, so DCG. Okay. For DCG, it's that angle, and it measures between 0 and 90, they say, and that it'll be an acute angle. Just remember, if it's smaller than 90 and between 0 and 90, it's so acute. Okay. And here, just for the color scheme. All right, so let's look at the next one, ABF. ABF, ABF. So ABF will be here, and that is what we call an obtuse angle, okay, which is basically 90 degrees. So your angle measurement is basically going to be more than 90 but less than 180, okay, degrees. All right, last one up, KCG. 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 Okay, it'll be right there. And if you notice, that 2 seems pretty adorably acute. You can also probably try to figure out other angles, if you will. And remember, BCK was 90, so chances are KCD will also be 90, because if you notice, BCD is 180. Okay, and 180 is basically comprised of two 90s. So that's something to also to note. All right, number 9. Number 3. Number 3. We have to draw and label a diagram based off the situation. Now, they say points C, D, and E are collinear. What does collinear mean? It means multiple points existing on the same line. They are coexisting on the same line. Okay, so we're focused on C. They do tell us that D is between C and E. That's nice of them. And there's our little segment. They do say draw the segment, so that's why it's not like going on and have arrows passing through C and E, okay? All right, so they have this following information. They say CD is 4x, CE is 6x plus 2, and DE is 37. So to make this work, because algebraically it's kind of a mess, I believe, I'm going to change something. I want to change, I believe, CE. So basically, let me make sure I do this right in my head. Oh no, we fixed it. Go team. Okay, so it looks like we fixed it. Now, again, CD, they tell us is 4x, which is the algebraic expression for that little line segment. CE, remember, is the whole segment, okay, is 6x plus 2. DE, they give us 37. And then we're going to set this up algebraically. So there's the diagram. We did it correctly. Now we're going to find the measure of CE. Well, we know that CE equals CD plus DE. Make sure you explain why, and that's because of the line segment addition postulate. All right, so CE we remember as 6x plus 2. CD is 4x. And DE was just 37. This part was because of substitution. So make sure you include the reasoning. Okay, we just substituted. All right, let's go ahead and use the subtraction property. And if you like, you can use the subtraction property for both sides. Okay, so we actually used subtraction property of equality twice. Okay, one for the 4x and one for the 2. We have 2x here. These cancel out, and these terms cancel out. And you're left with 35. And now how to get rid of a multiplying 2? Division property. So again, this is the division property. And x equals, I believe that will be 15, 16, let's see, 1, sorry, tired, 17.5. Forgive me, my brain is sluggish. Long day today. All right, so is that our answer? Is that what they were asking for? Do we box it? No, this is not our answer. We are looking for the measure of CE, not for x. So all we have to do, again, CE equals 6x plus 2, and we said 6, or I'm sorry, x is just 17.5, and now we're just going to substitute it in. Okay, so forgive me while I use my calculator because I am very tired. Let's see, 17.5 times 6, 105. Okay, so we get 105 from there, plus the 2, and we're going to get our final actual answer. CE equals 107. That is our answer, okay, and that is for part B over here, okay? All right, use a straight edge and a compass to construct an angle bisector. Make sure you do not just draw a line down the middle, okay? I did do this in class and I used a protractor, it would work if you want to use a protractor. And basically all you have to do, I wish I had the tool here, oops, is let's say for example I used a protractor. You want to place your protractor's little hole on the base plate, okay, on the vector. Or I'm sorry, not the vector. Wow, super tired. Okay, vertex. Okay, so you're going to line it up, and you're going to line up with one of your rays. Now, if you line it up with, I believe, this one, this ray, you're going to work on the inside of the angles, okay? So you're going to get a measurement. You're going to mark it from this ray to the one that you're lined up on. Let's say I measured 40 degrees, okay? What you're going to do is you're going to measure out 20 degrees on your protractor and mark a mark right there, okay? Why? Because a bisector, bi means two, so basically your bisector equals half of whatever your angle measurement is for Q, okay? So we measured 40 degrees, and half of 40 has to be 20, and that's where we get our marking from on our protractor, okay? You're going to finish drawing your line. You have to forgive me, my lines are not perfect with this writing tab. But basically, you get the gist. This should be 20 degrees. Therefore, this guy should also be 20 degrees. These guys are angle bisectors. I should see something like that on your test, and you'll be okay. All right, number 5, indicate whether each of the following names of the angles are correct. Okay, let's talk about this. All right, we have angle M. Angle M in this situation would work, okay? But it wouldn't work if you actually had another angle that came from angle M, okay? So let's say this is O. Angle M, so not with what we call, I believe, is a linear pair, okay? So that won't work with a linear pair because you don't know which M we're talking about. Are you talking about this angle? Or are you talking about that angle, okay? But by itself, I would totally understand, okay? But not if it has a linear pair. You wouldn't know. So I'll go ahead and say no would work for not linear pair by itself. Yes, I would understand it in a general conversation. Okay. NLM, would that work? NLM. Well, first things first, what's our vertex? M, right? Our vertex has to be in the middle of the name, and it's not. So no, that would not work. Okay. NML, the vertex is in the middle. That works. Okay. Another way that would work is if you had angle LMN, that would work too. Okay, so just note that. So that was part D. Yeah, part D is right there. Okay, number 6, using the coordinate plane below to answer the following. So let's find the midpoint between G and T. So remember our midpoint formula is really just take our x values, divide by 2, and then comma, take our y values, divide by 2 as well. So let's see, our first point, point 1 is technically G, so x sub 1 is -5, y sub 1 is 6, x sub 2 is 3, and y sub 2 is 2. So we take our x's, -5 plus 3, divide by 2. Take our y's, 6 plus 2, all over 2. Sorry, terrible 2's. There we go. And now our midpoint will be -5 plus 3 is -2. Divide by 2. 6 plus 8, or 6 plus 2 is 8. Divide by 2. and we'll finally have a midpoint at -1, because -2 divided by 2, comma 8 divided by 2, which is 4. So our midpoint is right here, -1, comma 4. That's our middle. You can even just see it visually if you're just trying to stare at it. You can kind of see how well this guy goes down 2, this guy goes 1, 2, 3, 4, and this guy goes down 2, and then he still goes over 1, 2, 3, 4. So that's kind of preluding to the Pythagorean theorem if you're just using the Cartesian plane, which is all those little boxes. All right, so the distance formula. Let's go ahead and use the distance formula. So remember, the distance formula equals the square root of x sub 2 minus x sub 1, so the difference of the x's, squared, because you don't want a negative, plus, because now we have to factor in our y's, the difference of y's, so y sub 2 minus y sub 1. And don't forget we have to square that also, so we don't get a negative. And now we're going to substitute it in, okay? So x sub 2, again, was 3, minus our first x, which is -5. Notice I'm using the parentheses to make sure I'm aware of the double negative. And our y value for y sub 2 is 2, and our last one is 6. And don't forget we're squaring that as well. Okay, 3 minus a -5 is really just 3 plus 5, okay, double negative. So that'll be 8 squared. And then plus 2 minus 6, which is -4. Don't forget we're still squaring it. 8 squared, 64. -4 squared, 16. And we should be, here we go. We should be going down here to square root of 80. Now, if you type this in a calculator, it'll be an approximation. That means I would like it to be in the hundredths place. Okay, so some number, point something, something, okay? Or even better, if you want to be a true pro, you can go ahead and use the factoring tree. Okay, so we all know that this is 2 times 40, and 40 is really just 2 times 20. 20 is just 2 times 10. 10 is really just 2 times 5. Okay, I know this was, I believe, 8th grade. So these are our lowest common factors. These two 2's can get the square root of and give you a 2. These two 2's can take the square root of, get you another 2. So you'll have a 2 outside with another 2. The 5 can't get out. 2 times 2 is 4. And all you're left with is this. This is the exact distance. Okay, that's the exact answer. This would be the approximate. All right. Okay, there is another way of finding the distance. Okay, Pythagorean. So let me clean up this real quick, and so I can show you what I mean. Okay, so if you notice, I drew a line between our 2 points, G and T. And if I was to use Pythagorean, I would draw a perfect right triangle, which you can using a Cartesian plane. You would notice you have 1, 2, 3, 4 of a length for that leg. And for your base leg, you have 1, 2, 3, 4, 5, 6, 7, 8 units for the base. Pythagorean theorem may be applied here, okay? So remember, Pythagorean theorem is really just a squared plus b squared equals c squared. Now, a squared doesn't really matter which leg is which. I always like a being the smaller one. So 4 squared, okay, I'm just substituting. So I'm using this 4 right here, plus b squared, which is really just the 8. So I'm going to do 8 squared equals c squared, which is really now, just to be aware of, is really just g t squared, okay? Because again, we're finding the line of gt. So gt squared, how do we get rid of the square for gt? We square root both sides. So again, you should be able to get the same answer as earlier in the distance formula, okay? You're still going to get the 16 plus the 64, all being square rooted for gt. You're still going to get that square root of 80 for gt. And it's still going to be 4 square root of 5 in the exact form, okay? So notice how you can double check yourself to make sure you did everything correct. Very useful. All right, complete the proof and justify each step. So last part of this is setting up the logic. They do give you a terms bank, so subtraction property, angle addition postulate. So we're going to use those to get our stuff going. So first things first is they give us an angle here, all right, a very large angle, and they tell us the expression for this part of the angle, and they tell us this expression for this angle. Now we know that due to the angle addition postulate, that we may actually take GTS, angle GTS, apologies, set it equal to GTH, angle GTH, apologies, plus HTS, angle HTS, okay? So that's the angle addition postulate. So we're just setting them to that because we know this whole big guy, this big angle GTS, is comprised of these two smaller ones, okay? And really we just add them up together. All right. So next thing you know, as you can see, it looks like we are combining like terms. Good old algebra. And then finally, we are, looks like, subtracting this 4x to both sides. So that's the subtraction property of equality. And then we ended up taking care of this minus 15 by using the addition postulate, or property, sorry. Lo and behold, last round, division property to isolate our variable. And then notice how the x was on the right hand side, and then we just do a nice little script flip. Okay, now people say flip, but in reality this is the symmetric property. Okay, all right, that concludes everything going on. Good luck, and let me know if you have any issues.